This module here is the lesson where I'm going to give you quite a bit more explanation if you still need more practice for how to do our nomenclature. Okay, so in your notes you have lots of practice questions for naming ionic compounds, and this is where you have all three together. Okay, we did the monovalent, the easiest ones, the group 1s and 2s, the ones where you can figure out what the ionic charge is based on the group number. You will also see you've got the multivalent ones in here. So this is where you're going to look on your periodic table. And is it one of the transition metals? And if it's one of the transition metals, then you're going to need to identify and figure out which of the two charges it possibly is, and then make sure that your name reflects that. Okay. The third kind that we did was the polyatomic. So these are the lists that we didn't have a chance to memorize them this year, but go ahead and do that if you'd like to get a head start for grade 11. Just being able to look through and identify the fact that, for example, this one is chlorate. If it was chloride, it would just be chlorine. But this is a polyatomic called chlorate with chlorine and 3 oxygens together grouped with a 1- charge. Same thing with nitrate. Okay, so you can look at that and be able to identify if they are polyatomics or not. So you have to be able to take the formula and write the name, and then we have to be able to take the name and write the formula. So depending on how much practice you want to do, there's so much practice you can do on these pages over and over again to get it. Then I grouped them where this page here has all covalent compounds. Okay, so this is your practice where you take all the molecules that are made up of all nonmetals together, and there are some common named ones here. So water, hydrogen, methane, you've got your diatomics in there, and again, this page has all just practice on molecular. Once you get to be very familiar with all of them, then you can just put them together and say, okay, I'm going to start at the top and go down, and you identify them first. Is it ionic? And which kind of ionic? Is it multivalent? Does it have a polyatomic in it? Or is it molecular? And then you follow the naming rules for the particular kind of compound that you've got. Okay, so if you're done and you've practiced enough and you feel good, then check your solutions. Again, continue to practice as much as you'd like. Being able to name compounds is quite important because the next step is to being able to put the names of compounds into properly balanced chemical formulas, and then being able to identify how many you have. So we have to do some balancing of chemical reactions, and it's all based on being able to do your naming properly. Okay, so spend a bit of time on this. This is the basic part in chemistry. If you need more practice, then you're going to keep following along with me. I am now going to move into doing a one practice solution for each of the 4 different kinds. So again, you can stop the video if you're done. And if you need more practice, let's do some examples. I'm going to show all of the work for how to do each of the 4 different kinds of naming ones that we did. Okay? All right, I will post this, but here we go. Example number 1. I want you to be able to write the formula for the compound that's called potassium sulfide. Step number 1, you classify the compound as either ionic or molecular, and then you know which rule to follow. So this has a metal and a non-metal. Potassium's on the left, sulfur is on the right side of the periodic table. When non-metals and metals come together, they come together in a particular ratio of those ions, and so therefore it makes an ionic particle. Okay, this is an electrostatic attraction. So 2 ways to show my work for this. The first way is the easy way. Hopefully you're already here by now. You write down the charge at the top of each of the ions. Potassium has a 1+ charge. Sulfur is in group number 6. It has 6 valence electrons. Therefore, its ionic charge is going to be 2- because it wants to have a happy, stable octet. You take the ionic charges, crisscross them down to give you the ratio that those ions are going to be in. So you know that the 2 is going to come down. I'm going to end up needing 2 things with a 1+ charge, 1 ion with a 2- charge, so that my formula for potassium sulfide is K2S. Can I show it a different way? Yes. Let's go back to grade 9. In grade 9, you showed a Lewis dot structure. You can take the Lewis dot structure, so I've got 1 valence electron for each of the potassiums. I have 6 valence electrons for the sulfur. I actually show the transfer of those electrons, that's what we do for ionic. The transfer electrons gives me ions. Two things with a 1 plus charge, one thing with a 2 minus charge. My formula is K2S. That's the rough work. Now, can you do it just the cheater version? Just show you how to simplify this because you understand how these ions come together. Potassium and sulfur will always come together in a 2-to-1 ratio and make these lattice structures that are characteristic of ionic particles. Okay, next one. The second example is using a metal that's a transition metal, meaning that if you see 4 in the name, then clearly that's going to be the lead-4 ion that we're talking about. So lead-4 sulfide, okay, ionic. It's one that's multivalent. So I have to take note of that because that's going to help me out when I have to write the formula. How do I know? I know it is a metal plus a non-metal. So again, that's the rough work I do up here so that I can make sure I'm going to use the right rough work when I make the formula, and I'm going to use the correct naming rules. Okay, so I'm using my naming rules for an ionic particle. Let me move that down so you can just see. Lead-4 sulfide. So here I go. Pb4 plus. S, again, use your periodic table to remember that it's S2 negative. I use my ionic charge to the crisscross rule and I bring it down. Pb2, S4, because it's ionic, you need to reduce it to the lowest whole number ratio, PbS2. That's my final answer. The name of that compound is lead-4 sulfide. Could you do the reverse work to figure out the name given the formula? Yes, I'm sure that you can. Okay, now, do you want to see the rough work for this one again? Yeah. If you don't understand the zero-sum rule, then I want to show you how to do that one more time, okay? This is basically saying, how do I know how many of each of those ions are going to be in the formula, okay? So this is where I go. How many leads plus how many sulfurs will add together so that the charge on my overall compound is going to be 0, okay? How many of each? So I know that my charge on lead is +4 because it told me so in the question, right? Lead-4. Therefore, it's the ion with the 4 plus charge. How many sulfurs? Sulfur has a 2 negative charge equals 0. Okay? So how many of each? This is where you figure it out. How many of these and how many of these can add up together to give me 0? Okay, well, I know that I can have one thing with the 4 plus charge, and I'm going to have two things that have the -2 charge to give me 0, because that would be +4 minus 4 equals 0. Pb1, S2, and where do those numbers come from again? Let me just show you a different color here. Okay, this one is right here. There is one, and you don't have to write a 1 because by writing the element Pb, that shows you that there is one. And what about the sulfur? How many sulfurs? Right, 2 things with a 2 negative charge, and that's where the 2 comes from. So my answer, PbS2. That's using the zero-sum rule. And again, if you understand the zero-sum rule, use the cheater version, use the crisscross rule. It is the exact same thing, but you have to be able to understand where those charges come from, right? So that's the showing your work. That means you can show, you're demonstrating your understanding. Let's move to the next example. So that's 2 examples of the 4. Example number 3. Here's where you've got a polyatomic. Okay, there are 2 examples on this page, and I'll talk through both of them. The first one, tin 2 hydroxide. Tin is a metal. Hydroxide is a polyatomic. It's the non-metal that's the polyatomic. So this is an ionic particle. Okay, I'm going to use the ionic naming rules, which means I can use the crisscross rule. Tin 2 tells me I have the tin with the 2 plus charge. Hydroxide has an overall charge of 1 minus. I use the crisscross rule, bring the 2 down here and the 1 down here. This shows me I have 1 tin and I have 2 hydroxides. That is a particle made up of 1 tin and 2 hydroxides. Can you see here that this 2 refers to the fact that if I were to count the total number of atoms in this particle, I would have 1 tin, 2 oxygens, 2 hydrogens. In total, there would be 5 atoms, but I need to put the brackets around my polyatomic because this refers to 2 of these whole things, okay? What does that look like? If you want to show your zero-sum rule, how many tins and how many hydroxides? Okay, hydroxide has a 1 minus charge, tin has a 2 plus charge, plus 2 minus 2 gives me 0. So I know I need 1 of these and 2 of these, and I get the same answer, SNOH2. Okay. The next one here is the exact same kind of example, but this is just a regular ionic compound with a polyatomic, but we're dealing with magnesium. Magnesium is a group A metal atom because it has a 2 plus charge. It's in group number 2. So you don't have to tell me which one because there is only one magnesium ion. Okay. Crisscross rule, 2 plus, 1 minus, crisscross them down, tells you the ratio that those ions are going to be in. Okay, and again, I did both of the rough work for this page here. Can you see where I've got my Bohr-Rutherford diagram here? If you wanted to, you could do your ions, show the transfer of those ions, show what ions make, show the ratio that they come in. Okay, zero-sum rule, same thing. I'm going to get the exact same answer. So there are really 3 ways to show your work for ionic compounds. Okay, the last one. This is a covalent compound. I can see that the name of this compound is carbon tetrachloride. I have 2 nonmetals coming together, and so we use the simplest way that we use for naming these compounds. You simply write it out, okay? If it's carbon tetrachloride, I have 1 carbon. We don't have to put the mono in front because by putting carbon, it shows that it is only 1. And then chloride, it tells me how many of the chlorines there are. There are 4, tetra. 4 chlorines. You change the ending to IDE, and if you wanted to show your rough work, the rough work for this one is to show the sharing circles, right? Because those electrons are going to be shared pairs, and then that would be like carbon tetrachloride. If these were chlorine, imagine this is what the molecule would look like. Okay, so that's your shared work. Do you do the zero-sum rule for here? No. Not for molecules. That is only how you show it for ionic particles because, again, those ions have charges and you have to make those charges equal to 0. Okay, no such thing for the molecules. On the back of the sheet, there are a few more examples. So this is where you need to go backwards. So if you were given CaBr2, I recognize this as an ionic compound. It's simple. It's got a metal and a nonmetal together, and so I'd name it using the simplest rules. Calcium, bromide. Add the IDE, and that's it. Okay? Show the work for that if you wanted to. Next one, PbS2. I recognize this as an ionic compound. Again, it's lead. So my lead, how do I know which charge it is? I need to be able to tell it in the name which actual lead it is. And you can use your periodic table. Is it lead 2 or lead 4? Can you do that in your head? Do I know it's lead 4? How do I do that? Use your zero-sum rule if you need to. And now it's like I know that I have 1 lead and I know that I have 2 sulfurs. So now you're trying to figure out what the charge of the ion of the lead was. And so you use the zero-sum rule here to figure out that it's lead 4. So therefore, when you do the name, it's lead 4 sulfide. If you can do that math in your head, then you're good to go. Okay. Last one is tricky. The last couple on here because, again, you've got some polyatomics. So you'll get really good at that. Do you know that that's just going to be beryllium phosphate? That's an ionic particle where you have 3 ions of beryllium and 2 ions of those polyatomics called phosphates. Beryllium phosphate. Next one, Copper nitrate, which copper? It's multivalent, so you need to reflect that it's going to be copper 2. I can do that crisscross reverse rule in my head because I know that a nitrate has a 1- charge. So clearly it's going to be the 2 charge on the copper because you need one thing with the 2 plus charge, 2 things with the 1- charge to make that sum equal 0. Okay, last one. Sulfur and fluorine, those are both nonmetals, so now I just use my prefixes to tell me how many of each, and that one is sulfur, hexafluoride, and should I do the Lewis dot structure for that one? No, it's way too complex for us. Okay, so that's it. That's all the review. Do you need more help? Let me know. If you have a specific question, I can show you, but again, it's just really to do with practice, practice, practice. So good luck and let me know how it goes.